as I mentioned at the end of the last video, first thing I want to do is subtract that 2 over to get one side equal to 0. So we'll have 3 cosine squared theta plus cosine theta minus 2 is equal to 0. And again, I'm hoping that this is the result of FOILing. So I'm hoping that I can find 2 binomials that are going to multiply to give me 0. In order for my first terms to be 3 cosine squared theta, I'm going to need a 3 cosine theta and a cosine theta. Okay. Now, if my last terms are going to multiply to give me 2, I'm thinking I need a 1 and a 2. Okay, not a huge long list of possibilities. Again, this is going to have to be negative. Okay, so one of these is positive and one of them is negative. But I do need to be careful here because these guys aren't the same. Whatever number I put here, I'm going to end up multiplying by the 3 cosine theta. And whatever number I put here, I'm going to end up multiplying by the cosine theta. So there's a little bit of trial and error here. If I were to put the 1 here and the 2 here, notice that would give me 6 cosines and 1 cosine. I know I'll be subtracting because one's positive and one's negative, but that's not going to give me just one copy of cosine. So that's enough to tell me that if this is going to work, the 2 is going to have to go there and the 1's going to have to go there. That way the outsides will be 3 cosines and the insides will be 2 cosines. Now if I want to end up with a positive cosine, I need that bigger product to be the positive one. Now notice, that's not the bigger of these two numbers, that's the bigger of the outside versus the inside product. So let's double check. 3 cosine squared plus 3 cosine minus 2 cosine gives me 1 copy of cosine minus 2. I'm liking it. Okay, so now 2 things multiply to give me 0. One of them's got to be 0. So 3 cosine of theta minus 2 equals 0, or cosine of theta plus 1 is equal to 0. Okay. All right, here, if I add over that 2, 3 cosine theta equals 2, cosine theta equals 2/3. Do want to just double check. That's between 1 and negative 1, so that's a valid number, so we'll keep going. So cosine is positive in quadrant 1, so I will have a solution there. Okay. Cosine is negative in 2 and 3, but it's positive again in quadrant 4, so I'll have a solution here. Okay. Now, usually when we work with inverse trig functions, they're going to be in radians unless otherwise specified. This was otherwise specified. Okay. So when I use inverse cosine in finding things here, it's pretty much understood because I'm saying my solution is between 0 and 360 degrees. I mean inverse cosine in degrees. Okay. Unless it's specifically stated, though, it's always assumed that we're in radians when we use inverse trig. Okay, so this is just an acute angle whose cosine is 2/3. So that's going to be theta is arc cosine of 2/3. That's going to be my reference angle for this one. The acute angle whose cosine is 2/3 is arc cosine of 2/3. So here my theta is 2 pi minus alpha, or 2 pi minus arc cosine of 2/3. Okay. So those are 2 solutions right there. I'm going to get arc cosine 2/3, and I'm going to get 2 pi minus arc cosine of 2/3. Okay. Now I need to look at this one. If I isolate the cosine, I'll get cosine of theta is -1. And I recognize that's actually the smallest that cosine can be. So that's also going to correspond to a quadrantal angle. Remember that cosine is the capital X value where we intersect the unit circle. So that's going to happen at this point, whose coordinates are -1, 0. And the angle between 0 and 360, where that would happen, would be 180 degrees. So I've got 3 solutions between 0 and 360 degrees. If I want all solutions, it will be arc cosine of 2/3 plus n copies of 360 degrees. Don't forget the degree sign here, because when we're working in degrees, we do put that symbol. I suppose, well, I guess it's understood here that this is in degrees, so not necessary, because it's not 2/3 degrees. It's arc cosine of 2/3 would be given to us in degrees. But I should put it around the 360. Okay. Oh, and I'm sorry. Here I wrote 2 pi. I'm so used to working in radians. That should have been 360 degrees minus arc cosine of 2/3. My bad. We don't want to mix the two. If we're in degrees, let's stick with degrees. So I would have 360 degrees minus arc cosine of 2/3 plus n copies of 360. And because that's just one copy of 360, if I want, I can let that be absorbed in here. So it's not necessary to write that, although it's certainly not wrong to either. And then I would have 180 degrees plus n copies of 360 degrees, and all of this where n is an integer. So that would give me all of my solutions to this problem.